Good afternoon, everyone. This is Dr. Latriciano. Welcome back to THS 8103 and Nursing 8452. It always takes me a little while to get that right. I hope you all had a nice holiday weekend. I'm sure some of that holiday weekend was spent doing some work, but welcome to doctoral work. Today, what I want to do is review a little bit of what was addressed in session one, give you sort of some clues as to the most important pieces of session one, and then talk a little bit about where we're heading in session two. So session one is really, just as we stated, an opportunity to understand the landscape of team science, and some of the readings we gave you this week to focus on were really meant to sort of give you a very broad sort of understanding of both the literature and the issues that we are often found in team science. The National Academies of Science report on enhancing the effectiveness of team science, this little book here, was a culmination of leaders in our field. If you thumb through the contributors, you'll notice that some of those contributors also come up as authors in the literature we'll be reading. But it has been, ever since it's been published, which hasn't been that long ago, about 6 years now, a sort of go-to document that gives the overall sort of viewpoint that team science and the science of team science take. And in the first 5 chapters, the reason why I asked you to take a look at those chapters in particular is to start to understand the language, the issues, the frameworks in which the study of teams adopts. And this isn't just to understand sort of the nomenclature of the team science literature, but rather also to understand how these are real problems that are researchable in teams, and there is evidence that is emerging from the field that supports the study, evidence that supports practices through the study of teams. It's usually around this time in the semester, which is very early on, where we start to recognize that there's a difference between science teams and other types of teams. And what I mean by that is, in your reading, hopefully you keyed in to the idea that we are talking about teams that are knowledge producing. We might call them research teams or science teams. And in the world of clinical research and health care, I often find that students can often sort of intermingle what it is that team science is trying to achieve and the science of team science, and parallel it with some of the work that's done in effective performance teams. Like, for instance, in a couple of the uh, discussion boards, I saw some things being brought up like team steps, for instance, and why doesn't team steps enter into this literature that I've introduced you to? There's a good example of how that sort of team training and the protocols and the best behaviors that go into teaming are not always the way the team science approaches it, because team science is predominantly the study of teams and also the study of science teams. So you can understand the parallels that might go on between care teams in health and medicine, and possibly the research teams that are involved with health and medicine. But in fact, hopefully you've seen that in the literature that we've asked you to read, that the teams that conduct science together are often more organically brought together, not quite as systematically brought together, like in health professions, where you have doctors, nurses, therapists, et cetera, even people responsible for environmental services, et cetera, who have very well-trained and structurally predictable positions in a healthcare system that has competency requirements and that sort of thing, and scientists who come together because they have similar interests, but they do not have shared competencies. They do not sometimes even have competency-based disciplinary background, where all anthropologists are trained the same. No, not all anthropologists are trained the same, nor do they have any sort of base competency like, for instance, a healthcare worker would. Let me just highlight a few of I think the more important points in the reading. So in the National Research Council document, I really like page 27 and following, where it highlights some of the goals and potential challenges for teams. These are things we see all the time in research: high diversity of membership, how deep knowledge integration might be achieved, team size. It says large size teams, but really team size in general, and what's the optimum size for teams to work. It's very hard to know. Things like the CERN project in Switzerland that is working on splitting the atom. There are 3,500 scientists, which all of them published together. That's a very large team, and you have to ask yourself, how is it even possible that that can be done? So it's very hard sometimes to get your head around the idea of what is an appropriate team size, and then other items that you read there. I think these pages are really helpful to understand what makes science teams unique, because some of these items, though you may see them in teams like care teams, and even baseball teams for that matter, they're very specific to science teams. So how knowledge is integrated, not just how people perform their tasks. Group boundaries, boundaries around some disciplines versus other disciplines, and some of them are very strict and strong, while other boundaries are a little bit more permeable. Geographic dispersion. Today, scientists work with each other from all over the world, and they are not always in the same place. And as we know, especially in this last year and a half, there's something different about digital communication on distance versus face-to-face. The old adage was, in the old days, you could walk down the hallway and talk to people in another lab. Well, that's really not how science is conducted completely today. There's much more diversity in geography, diversity in the type of backgrounds that scientists bring with them to solve very complex human and global problems, where it's really important to ensure that we have both specialists in areas, say for instance, like coastal flooding, and at the same time, we have people that are on those teams that are the victims of coastal flooding, and architects, and people who study climate change. These are diversity of disciplines that often do not have common vocabularies to work from, even though it's important that they have similar mental models, meaning what is the problem they're trying to solve, or what is it that they are trying to create and or integrate when it comes to knowledge. So again, I think there's a great list on page 48 and following of what the concerns of the science of team science are. And a few pages later, I believe, oops, sorry, wrong one. wrong page. It goes down and it looks at each one of the main concerns in more detail. Now, I know you're not thinking about this right now, but as you are sort of digesting these distinctive concerns, you might think to yourself how your interest, whatever it might be, or whatever might come in the next year or two, can embrace one of these major concerns from team science as a way to do doctoral dissertation work. So for instance, I'm just going to use the second one. It's on page 50, understanding the multi-network structure of contemporary scientific collaborations. If you're interested in a particular disorder, disease, especially those types that utilize networks of scientists, not just like one lab or one site, but rather sites throughout the country or possibly throughout the world, and you have a particular interest in a condition like diabetes, or maybe obesity, or maybe something rarer like a metabolic disorder. Understanding how those networks of scientists work together would be a concern of team science. So you can take an approach towards how to study those sorts of things using some of these concerns that are outlined here in these chapters. Also, I want to draw your attention to page 73, because I think it's really important to understand these issues that we study in team science, in the science of team science, excuse me. How do they really help people? How do they change things for the better? And I think table 3.1 gives you some really good ideas. The research that we do in the study of teams actually can provide empirical support for interventions. So it's through the research we do of teams that we get ideas about how we can help teams behave in ways that are much more, that ensure in greater detail what the type of intervention to create stronger behaviors, stronger cognition, stronger attitudes that will ensure greater success. There are challenges in team science too, and on page 93, the authors talk a little bit about it. High diversity of membership is a very hard thing, especially when you have people from different disciplines that speak different languages. I don't mean linguistics. I mean, speak in different ways about things. A statistician speaks a certain way, as does an oncologist, as does someone from the humanities, for instance. They use different words. That high level of diversity is a tough thing to cope with. Also, how to really get into deep integration of knowledge where you no longer just talk about things in 5 different ways, but you start to integrate it in a way where everyone can find a solution that is the culmination of contributions from different types of disciplines. I talked about geographic dispersion a little bit. That is a difficult feature and a growing feature in conducting team science that requires attention. And the idea of high task interdependence, meaning you can't just go off into a corner and do your part. You need to be very interdependently involved with others on teams. So again, I'm just drawing out some key features of what this book can provide you. It is the work of team scientists, meaning people who study teams. And if you look closely, you'll see some of these people come up again in other literature that we're going to be talking about. So of course, as you all wrote, and it was great reading a lot of the posts. I didn't read all of them yet, but I read a lot of them. As to which of the things you've been reading about are challenges. It's not surprising. When you look at the subsequent literature I gave you to read, Dices and Slattery, Wuchie and Jones, and Utsi, and Nurius and Kemp, these are sort of opportunities to sort of imagine what the possible solutions are to these challenges. So in each case, the authors make a case for why it's important to, for instance, take very seriously what we get out of multidisciplinary team science. I always say the reason for team science is that we do cross-disciplinary work, that it's not just five, excuse me, five cancer researchers that all happen to be oncologists working together, but it's cancer researchers that include physicists and include pulmonologists and include possibly even integrative medicine people. It's when you bring those people together, you have that multitude of perspectives, which really can create much more knowledge around a particular case, like, for instance, a heart disease or something like that. And sometimes we don't even think about the types of disciplines involved until once we realize that the heart is a machine, and that machine is affected by gravity. Well, that includes cardiologists, engineers, and physicists. And we might not think of the heart working that way, but when you bring together people with different perspectives, we can think of the heart that way, and in fact, provide better solutions to particular problems. I hope you also notice that in Wuchi, Jones, and Utsi, this isn't theory. It's not just made up. It's the, let me see if I have this one open here on my, nope, not that one. See if I can find it. Here we go. So it is based on research. Now, this particular paper, it's very short, as you know, actually looked at the impact of teams on research that gets cited, and it even shows here, if I can open this up a little bit, I'm not sure I can, about how in different fields there's a growing predominance, and this is a little old, it only goes to 2000, but there's a more and more evidence that there are more and more teams publishing together. Now you might ask yourself, well, why does that even matter? Well, because what we also finding is that those who publish in teams often are cited more. And if you think about it, it's really not rocket science. If you have people who are from 5 different disciplines, say, well, they are representing and contributing to 5 different disciplines where that will be brought together by the influence of these scientists on the others on their team. So this particular type of analysis is called bibliometrics, and we will talk about that later. But as you can see, what we've tried to include in this session 1 is not just the nomenclature, not what the words are, not just what the issues are, but a little bit of how team scientists tend to work with these problems and how they tend to gain evidence from research around teams. This is the article in Science Translational Medicine by Dices and Slattery, and they have this great model here that shows the difference between sequential thinking and incremental innovation. This actually comes from a very old assumption about innovation that came from Thomas Kuhn, actually, that stated that innovation occurs sort of in spurts. Like, you know, we discover something, then a few years later, something else is discovered that's changed our mind on it, et cetera, et cetera. What they're showing here in B is diverse teams develop ideas through networks and leaders. This is not sequential at all. It's more connective thinking. And we tend to see more radical innovations that come from this sort of viewpoint. So again, in the first session here, it's to introduce you in a very sort of quick and dirty way what the landscape of the team science community is, so you can have an idea of what it is that team scientists do and those who study teams can do. And if you had the time to watch all of Dr. Fiore's overview of the team science agenda, you will see even more sort of nuggets of what is part of this field and how we uh, contribute to science through it. So now let's look at session 2 that we're going into. We will oscillate back and forth, somewhat like a pendulum, between the idea of team science and working in teams and the idea of cross-disciplinarity, because as I stated, cross-disciplinarity is sort of the reason why we do team science. So in session 2, we're going to talk a little bit with a little bit more detail about interdisciplinary studies and what sort of are the main components of that as we think about what the value is to work across disciplines. Many of you may have heard or become familiar with terms like multidisciplinarity, interdisciplinarity, and transdisciplinarity. In fact, I often see those words used interchangeably. Let me assure you, those people who are involved in understanding the different types of cross-disciplinarity do not interchange those words, and we're going to learn a little bit about it. But as you move from session 1 to session 2, here are some points that I think are important as we transition. I told you the first is that pendulum swing between the two main concepts of teaming and cross-disciplinary research. They have a synergistic relationship. Unit 1 was more about the team science agenda, and now Unit 2, Session 2, is going to be more about the cross-disciplinary discussion. The book Repko and Stotek, which looks like this, I think you all have an electronic copy of it, will be our guide through looking at cross-disciplinary research. It's very much a step-by-step guide, and you'll be working with this book a lot in the next couple weeks. Also, we have you read a really seminal work by Marshall Poole and his colleagues, who give us some insight into how we might look at a team and the lenses we might use. Now, for some of you who have not had too much work yet in research methods, this is sort of a warm-up to that, and you're going to read about different ways we can look at groups. Now, you may be thinking to yourself, well, what do you mean different ways? If you can think about any team you've worked on or maybe have observed, it's complicated, it's messy, and sometimes finding where you want to look as to what's going on in the team requires a dedication to a particular lens. So for instance, we might want to look at conflict. That's a lens that we're going to use to look at a team possibly. Or we may be looking at a team based on gender and gender diversity. That would be a different type of lens altogether. Or we might look at a team from the perspective of social networking and how they network with others and with each other and with others. So this article, which is quite short, it's not very long, believe it or not, is going to introduce you to those different lenses there, that I just gave you a couple examples of. And the way we're going to do this is give you an opportunity to work in pairs, and I'm going to scroll all the way down here to the session activity that says Theoretical Perspectives Wiki. And I've paired you up, and these are the 9 different perspectives. And instead of everyone trying to master or get around what every one of those perspectives looks at, or the way it looks at teams. We're splitting you up so we can create sort of um, a communal cheat sheet, if that makes sense. And I'm going to post here as soon as I'm done this video, the wiki, which if you've never used a wiki, it's just like working in a table. And you can update your material, and you can add, and in the different groups, which I will also refresh your memory and put all of those here. I just noticed I didn't update that, but I will. You all have an opportunity to share with each other what is behind each one of these different perspectives. Psychodynamics, functional, temporal, conflict power status, symbolic interpretive, social identity, social evolutionary, social networking, feminist, genderist. And as you can see, you're assigned one of those each. So as you read the paper, you might want to check in with your buddy that you're paired with and see how you're going to organize what it is about each one of these particular perspectives. There's also a little cartoon here that's going to tell you a little bit about the differences between multi, inter, and transdisciplinarity. And there's also a video here from, I believe, University of Pennsylvania on interdisciplinary research in science. I'm almost possible that I'm almost, or it's from London, I can't remember. You have some other reading. This is all meant to sort of get you thinking about the idea of why cross-disciplinarity is an important part of team science, and also some of the challenges that go along with working with people from different disciplines with different perspectives. So I'm going to continue to spy in on your postings. I was doing really well there. Then there was this glut of new postings, so I didn't get a chance to respond to all of them. Dr. Lay will also take some time and look at some of those as well. If you have any questions, as always, we tell you to go to the discussion board. Whoops, sorry about that. And you can put questions into the general question area. And I see there's a couple in there to respond to. I think I did respond to, yes, Laura put some questions there and I responded to them. If you, sorry, not sure what that's all about. If you post to those questions, general course questions, we try to respond quite quickly because we don't want you to get hung up in your work throughout the week. Again, great job this past week posting your responses to those prompting questions that we gave you. Let us know if you need help, and you'll be referring to the wiki as soon as I reset it. But have a good week, and everyone keep up the good work, and I'll talk to you soon. Bye-bye.